Okay, this is problem 4L, number 8. Um, so remember we are finding, just like in number 1, we're going to find A, the equation of the axis of symmetry. B, we're going to find the coordinates of the points where the curve intersects the x-axis, which is the same thing as the x-intercept. And then we're going to find the coordinates of the vertex. Okay. So let's look down here at number 8. So the axis of symmetry, remember that this is a formula that they give you on the um, formula sheet. So basically you're going to take the b coefficient, which is multiplied times x, and the a coefficient, which is multiplied times x squared, and you're going to put it in this expression, okay? So b is negative is 3, and so you're going to have negative, which comes from here, the negative's in the formula, and you're going to put a negative positive b, which the b comes from there, and then you're going to divide it by the a um, coefficient, which is 0.5, and 0.5 you're going to multiply times 2, right? Because it's actually 2a, it's not just a. So 2 times 0.5 is 1. I just made one step here, but actually you're saying 2 times 0.5 is 1. Okay, so you have negative 3 over 1 equals negative 3. So the answer here, you can't just put negative 3 because you're actually giving the equation for a line. If you're giving the equation for a line, you want to say x equals negative 3. So that would be a line, uh, a vertical line which crosses the x-axis at the point negative 3. So it would look like this blue line here. And of course the point where it's crossing the x-axis would be negative x equals negative 3. Okay, so that's what it would look like. This is the axis of symmetry of this parabola. Second step, we are going to find the x-intercepts of the parabola. Okay, so the parabola has this equation, and the way we're going to find the x-intercepts is with the calculator. And so this is, just like you've done in many other problems, you have figured out what the x-intercept is um, for lines and other functions. Now we're going to find the x-intercepts for a parabola. The biggest difference between x-intercepts for a parabola and for a line is the line crosses the x-axis at one point. The parabola might cross the x-axis at 2 points or less. So what we're going to do first is and we saw in number 1, remember in problem 1, we actually saw that there were no x-intercepts. It did not cross the x-axis. So this is why I'm going to show you problem 8 also, because in this one you actually are going to cross the x-axis. So the way you figure out where across the x-axis is you're going to put the formula in the calculator. So I can just put it in another, I could put it in for y2 instead of for y1. So I'm going to position the cursor at y2, and I'm going to put in this equation. So I'm going to put 0.5 x squared, and squared, there's a button here that does squared. And then I'll do plus 3x plus 3x, and then I'm going to subtract 4 minus 4. So I can put exactly that in there. Okay. Now what I need to fix here is, do you see how these two equal signs are black? We don't want both equal signs to be black because otherwise it's going to plot both of these on the graph, and we only want to plot one to be less confusing. So we go to the first one that we did before and we erase. We're not going to graph that. We're going to make the equal sign normal. So this equal sign is black, which means we're going to graph it, and this one is normal, which means we're not going to graph it. Now we press graph, it's going to graph the one we just put in. So there it is. So it says, where are the x-intercepts? Well, they're here and here. Now what is the coordinates of these 2 points? And it's hard to see in here, and there's a couple ways we could do it. One is we could do trace, and then we'll take, like, let's say we want to figure out what point that is. So we'll just push on this until we get about to that point. And we can tell when we're close to the point because the y is going to be close to 0. But you can see I can't get it to y0. It gives me negative 0.24, and then I press it again, and it gives me 0.644. So in order to see exactly what that is, we would have to use the calc. So if we do calc, we can figure out exactly where that point is. We're going to press second trace calc, and we're going to say 0 because we want to figure out what the zero, where the 0 is. And we're going to first put a point slightly to the left of the 0 point, and that, let's say it's there. Okay, so we'll adjust it so that we're slightly to the left of the point. We'll press enter, and then we'll go a little bit to the right of the point, and then we'll press enter again. And then it'll say, is your guess this? And that's fine. So do you see how it shows the two limits? Enter, and it tells me that the 0 is actually at 1.123. So we put down 1.123 here. That's the right x-intercept. Okay, now what is the left x-intercept? Okay, so we can go all the way to here. So we're going to use the, we'll do trace. We press trace again, and then we're going to move the cursor all the way here. If we want to move fast, maybe we could press -7 or something like that, and then it'll move it exactly to there. Hey, it's really close now. Okay. Okay, so let's move it slightly to the left of the point, and then we're going to do second calc again, second trace calc, and then we'll do 0. And then we'll see we're slightly to the left and left bound. Yeah, this is the left bound. And then we'll go a little bit to the right. And then you can see it's a little bit to the right, and now we'll press enter. And so now somewhere in between there's a cross that it's going to intersect the x-axis. And is our guess that? Yeah, that's close enough. And it tells that the 0 is -7.123. -7.123, we put the answer there. And the y-intercept, of course, is 0. So I give here the x coordinates of the two intercepts. I don't need to give the y coordinate because the y-coordinate is 0, obviously, because these are the intercepts for the x-axis. So that's one way you could do it. The other way you could find these 2 points is if you use poly-SMLT. So to use poly-SMLT, you don't have to graph it. You don't have to put the equation into y equals like we did here. You don't have to do that. You just go to apps, and then you go to poly-SMLT, and then you go to poly root finder. Remember last semester we did simultaneous equation solver. We're going to do poly root finder now. Poly root finder, we'll put order 2, and we're going to go down here. We're going to go next here. And you can see that this format is similar to this format. We are going to put in the coefficients here, 0.5, 3, and -4. And we're going to put them here, 0.5, 3, and -4. So first I'm going to put 0.5. And then I'm going to put 3. And the next one is -4. I can't, even though, you know, it looks like a subtract 4, it assumes that it's a add, so I need to put -4. And then I press solve. And that gives me the 2 zeros for this equation. And those, so like when does this equation make y equal to 0? Well, it makes the x at -7.123 or 1.123. Either of these two x coordinates make the y 0. So you can see it gives you the exact same answer. One reason why you might, in this case, use the graph instead is because right afterwards they ask you what the coordinate of the vertex is. And although poly-SMLT finds you zeros, it does not find you the vertex. So let's go back to the graph. Get out of here, second quit, and we'll go to the graph. Okay, now we want to know the vertex, which is right here. Okay, so we can see about where it is, but we don't know exactly where it is. Well, we do know the x-coordinate of the vertex, right? The x-coordinate of the vertex is the value for the axis of symmetry, which we know is -3. So this vertical part is going to be x equals -3. Now what's y equal to? Well, it's about here. So it's like some negative number, but we can't really see what it is. Now to see exactly what it is, we could use trace, or at least close enough, okay? So we're going to get kind of close to it and see where it is about. should be what x equals -3. So when x equals -3, we're pretty much at the bottom, about here, okay? So it's going to be close to -8, but let's figure out exactly what it is. Now to figure out exactly what it is, there's a calc function, second calc, which does that, which is the minimum. So if your parabola is scooping up like that, let's got like it opens up, you can press, if you use minimum, it's going to find you the minimum of the parabola, which is opening up. If you have a parabola that's opening down, then you would use maximum, okay? Does that make sense why? Okay, so first we're going to go a little bit to the left of the vertex, and then we're going to say left bound, yes. And then we're going to go a little bit to the right of the vertex, and then we're going to press enter also. And now we're just going to say, it says, is this your guess? And it just has to be some number close to that, and you say, sure. Okay, and then it gives us the answer. -2.9999 and y equals -8.5. You can see it's close to the value we saw before. Now, the x value we know is actually -3 because we found that in the first part. It says -2.99999 because it actually uses a kind of an estimate. It approximates it, so it doesn't exactly. The calculator is not smart enough to figure out what. With algebra, it uses computer techniques to figure out what it is. So that's why it's giving you such a funny number. It's -3. We already know that. The y is equal to -8.5. And so you can actually find this another way. So the way you would do that is you have the equation. Okay, if you know that the x coordinate is -3 already, which we do, you can actually figure out the y coordinate just by putting the -3 inside the formula. So if you put -3 in here, and you put -3 in here, and you add and multiply, you are going to get the resulting y, or the y that corresponds to the vertex. Okay, because this -3 is the x corresponding to the vertex. So we do that, 0.5, and then we put 3 squared plus 3 times -3. So x, we're always putting -3 into here. And so there's the -3. Why didn't I put -3 here? Because actually -3 squared is the same thing as 3 squared. So I just did a shortcut. I didn't write -3 here. But it's the same thing, -3 squared, -3 not squared, and -4, right? And so if we multiply this out, 3 squared is 9, times 0.5 is 4.5. 3 times -3 is -9, -4 continues to be -4. The result is -8.5. What do you know? That's what the calculator gave us too. Okay, so the calculator can always give this to you, or you could use it, do algebra if you want to.